So that's what the vertex of the parabola is, by definition. Again, it's where the graph, again, changes direction, okay? You know, in one case, it's the bottom point, so to say, and one case, it's the highest point, kind of like in a valley or a hill, if that makes sense. All right. Okay, so again, I'm just going over some stuff before we do some examples, but that's what the vertex is. All right. All right. Also, we have this notion of axis of symmetry. It turns out that the graph is symmetric about the vertical line that goes through the vertex. The graph is symmetric about the vertical line that goes through the vertex. And what do I mean by symmetric? If you were to imagine, like folding a piece of paper, if you were to imagine folding the graph about that vertical line through the vertex. So in this graph down here, the vertex would be the, what do you call it, the y-axis, which is also x equals 0, right? Because this is the vertex here at this bottom. And the y-axis here, as you can see, that's the vertical line through it. So if you were to imagine folding the graph about the axis of symmetry, both halves of the graph would line up. Both of them would. Both halves of the graph would line up. Good. Okay? But that's what the axis of symmetry is. So in this case, and actually, let me see if I can get back to it. In these two cases, so here, this is the vertex here. The y-axis passes through it. That's the vertical line through it. Here, the vertex is also on the y-axis. And the y-axis is the vertical line through it, as you can see. So that's what the axis of symmetry is. All right. Let's keep going. There's also, we saw one way to write a quadratic equation. You know, in definition, we saw that, right? Here's another way, actually. This is what they call the standard form. You have the same a from earlier times x minus h squared plus k. H and k are real numbers. Actually, k is f of h. In other words, if you replace x by h, you'll get k. Now, you might be thinking, although I guess it's really stated down here, why do we care about this form? Why not we just stick with the first form? This form actually tells you what the vertex is, for instance. You know, for instance, here, the point hk is the vertex of the quadratic, of the parabola. Couldn't think of the word, even though it's right there. It's the vertex of the parabola. So in other words, again, hk is that point where the graph turns around. Not only that, you can also get the axis of symmetry easily. It's x equals h. Okay, now how do you actually get this form? Well, you would have to complete the square. I don't know if you know that procedure or not. I'm not going to cover it for time consideration. I mean, it's a nice procedure to know, but again, for time consideration, I'm not able to go through it. Okay. All right. This was the other form, you know, the form from the definition. What's nice, though, is you can still get the vertex, though. You can still get the vertex. Namely, the vertex is actually given here. This is a formula for the vertex, so to say. Again, the domain, as before, is all real numbers. Not sure why. Okay. The vertex here, this is what you would use to get it. Negative b over 2 times a, and then you do f of that for the y coordinate. Remember, it's a quadratic function, so a is not 0, so this does make sense. And the axis of symmetry would actually be this. So what's nice is you don't have to, I guess in a sense, you really don't have to complete the square. You can actually get the vertex from this formula. also, you can actually go from one form to the other. You can go from one form to the other. Namely, if you had this form here, you can get to this form, the form in our definition, our first form, you just FOIL. That's all you do. But to go the other way, to go from our first form to the standard form, you complete the square. That's what you do next. Okay. And again, also from the formula, you can actually calculate h. It turns out that h is actually negative b over 2a, and k is just f of that. So, it's just something that's good to know, I think. Okay? I mean, completing the square is very useful. It actually gives you another way to solve a quadratic equation. For certain quadratic equations, it might be easier to complete the square, to use that method, so to say. But again, I didn't go over it, so we'll have to skip over that. Almost there. Before we can do some examples. This is really for any function here. The y-intercept is always f of 0. And to get the x-intercepts, you solve this equation. That's really more of a reminder of what I'm saying here. For quadratic equations, in this case, we're going to have this. The y-intercept is easy. It's just actually the constant term. For the x-intercepts, though, you have this equation to solve. Okay? And there you can use things like a quadratic formula. You can factor. You can, those kind of methods. And again, this is a reminder. It's like the third time. The domain is all real numbers. And hopefully from the graphs you can see. Here, let me go back actually. Here, from the graphs here, you can probably see, and really from here, I guess, as well, the range will depend on A, B, and C. But in fact, once you know the vertex, in a sense, you're home free. Because if you have the vertexes, if you have your A is positive, your range is going to go from the vertex, the y-coordinate, up to infinity. Whereas in this case, if your A is negative, the range is going to go from your y-coordinate all the way down to minus infinity, like so. That's actually what I wrote here. So, I mean, we'll do some examples. Hopefully, when we do the examples, it'll make sense. So. Okay, so we have that now. All right, let's do some examples. I think that'll help clarify what I'm trying to say. So for instance, let's say this was our quadratic function here, right? We have 2x squared plus 8x minus 3. So here we have a is 2, right? B is 8. And we have c is negative 3. So again, a is 2, b is 8, c is negative 3. So let's get the vertex. So to get the vertex, we have to calculate negative b over 2 times a. All right, so that's what we're doing here. So that's equal to negative 8 over 2 times 2, which is negative 8 over 4, which is negative 2, as you can see. But now remember, for the vertex, get back to it, we have to do f of that as well. I mean, we just have the x coordinate, but the y coordinate, we have to plug it into f, and that's what we're doing here. So f of that is equal to f of negative 2, right? And you just plug it in directly, you get 2 times negative 2 squared plus 8 times negative 2 minus 3, which of course is equal to 8 minus 16 minus 3, which is minus 11. So our vertex is this point. As you can see, that's our vertex. And again, x equals the x coordinate, x equals negative b over 2 times a. That's the axis of symmetry. So we also have the axis of symmetry here. And not only that, we can get the y-intercept easily. It's f of 0, which is just a constant term. So that's why I didn't show the calculation. It should be pretty easy. And we actually know a lot already. Notice that since a is 2, which is positive, we can actually get a lot of nice information. For one thing, we know the graph is going to open, let's see if I can draw this right, upward, like so, right? The vertex is at the very bottom, so this is where the vertex is. Let me see if I can draw an arrow to it. Okay. And we also have the range, right? Remember, since it opens upward, the range has to go from the y coordinate of the vertex to infinity, right? So that's what this slide said.